Welcome to our first flipped lecture where we're going to introduce racket and some basic data types and how to call a function. In our first class last time, I talked about or try to motivate why different languages actually sort of steer programmers in different directions to prefer certain constructs or certain approaches to a problem, even though ostensibly you could write any program equivalently in any language more or less. So, and I mentioned that in this course we'll be using racket, and we'll be using it fairly in depth. We'll be writing some larger programs, partly because I prefer getting an in-depth exposure to one topic rather than an overview of like 5 different languages and showing you 3 short programs in each or something like that. So, okay, let's start with racket. I think I mentioned why did I choose racket? I'm not going to be teaching you much racket. And if we're going to cover like I'm only going to teach you about 5 language features the entire semester. We're going to hit 2 of them or 3 of them today. And really, if I'm not teaching you racket, why are we using racket? I'm teaching you how little you might need from a language, and it's showing you a language with a very minimalist approach to doing things that is very much in contrast to, say, Java or other languages you might have seen. Let's start with Hello World, right? Everybody has to start with that program, I'm told. So, okay, let's go ahead and do a Hello World program. So sort of a Hello World program, and there it is. I'm going to go ahead and run this, and I have my program up in the top. It's an editor. And down at the bottom, we see it run, and here is the result, Hello World. So this sort of maybe just gives you an inkling of what I mean when I say racket is a minimalist language. You don't need a public static void main. Heck, we're not even doing a print line here. You could run this from the command line. I'm not doing that, but you could actually run this program from the command line and get that same output when you run it. Okay. Interesting. Feels like a trick, but, well, kind of, because we can put other things in our program. I'm going to go ahead and down here, I'm going to say 17. What do you think the result of running the program 17 would be? Let me get rid of this for a second. I'm going to run this program here, click on the green Run button, and run 17, and the result is, well, you're shocked to find it 17. I can actually go back and have both things up in my program window, and when I run the program, there are 2 results. And in general, what racket does, it goes from the top of the file down and just sort of reads each expression, evaluates it, and gives the result. Reads the next expression, gives the result, and so on. So it's a sequential top to bottom sweep of the file. I have inadvertently shown you the first 2 things I want to start with, which is some of the data types you can use in racket. This class is going to be data driven in a sense, and so I'm going to put a lot of priority on how do we represent different things. So we can have, just like in most other languages, you can have strings, which we can have in our program with double quotes. We can have numbers like 17. You can go ahead and have fractional numbers, of course, and you have negative 34.7. By the way, if I go down to the bottom window, this is just an interactive session. Once it's printed out the results of running my program, I can just type in things interactively here and get back answers. So yeah, we have different things we can go ahead and type. Numbers. We saw last time, actually, since I was using arithmetic as an example, that we can have exact numbers and inexact numbers in racket. I'm not going to worry too much about that distinction, except that to point out that, hey, wait, I don't have that. So I can have 3.14159 as an exact number to exactly 5 decimal places. I can also have an inexact number, 3.1415926535897932338462643383279. Okay. And do this, and actually you can see that this gives me a standard 32-bit or 64-bit number with a limited precision, a double, if you will. Okay, so 64, I guess, bits would be a double. So yeah, I can have this different, these different types in Racket. What else can I have in Racket? What other types do I have? What types do we have in Java? What are the primitive types? Booleans, okay? So I can have true and false. The way we type these in Racket is hash true and hash false. And if you like, you can actually use hash t and hash f. Those are both ways to represent the literal true or the literal false. Okay. So yeah, it's a little bit funny with that hash symbol there. What else? Characters, individual characters. In Java, you'd say something like, you know, for the capital A, you'd say tick, A, tick. In Racket, it looks a little bit different. It's hash backslash A. And that feels a little bit weird to me. I'm never quite happy with that. It's the same number of characters as it is in Java, but somehow the fact that they're both sort of funky characters, I don't know, I prefer working with strings of length 1 than I do characters. Oh well. See how the language is kind of steering me for totally inconsequential reasons, and yet it kind of does, yeah, make me feel one way about using certain data types or not. Okay, so yeah, what am I missing here? Numbers, strings, characters, Booleans. Let me go to my other window here where I have some notes. I think that's the main ones. There are more data types. If you go off and look, there are built-in data types. Regular expressions is a separate data type, as it is in, say, JavaScript, or Java util pattern for that matter. Input ports, like in Java, again, scanner, you know, something like that, you know, are data types. So we have, sure, we have other types of here data, but the primitive built-in ones that we're used to using are strings, numbers, Booleans. I feel like I've left something off here. Characters, symbols. Okay, so symbols are kind of interesting. Symbols I can go ahead and just use with the, I'm going to rerun this program here to avoid or declutter the bottom window. Symbols are things where I put a single tick mark, so it sounds like I'm making a character, but I'm not. And I can go ahead and put things like tick red or tick yellow. Okay, just an open tick mark, no close tick mark. These are symbols. Gosh, Java doesn't really have an analog of symbol. It has a enumerated type, and you can use symbols for enumerated types. That's something. But symbols are a little bit different. Think of them as strings where you're never going to do string operations on them. Okay? Hey, I need to represent colors like red, blue, green, orange in my program internally in my libraries. I'm just going to use these symbols, and I'm not going to be taking a substring of yellow and I'm passing it to my library and so on. I'm not going to be turning it to uppercase or anything like that. I'm using these actuals as symbols, the same way English people talk about symbols, and people often in semiotics or modern literature, symbol just it has no meaning intrinsically. It just refers to something else that a human reader might recognize. So tick red, tick yellow. And in fact, inside the language, the only thing you can do with symbols is say, hey, is this symbol the same as that symbol? That's the only thing you can do with symbols. So, okay, but they're actually quite handy. Okay, so those are a bunch of our basic primitive data types right here. So, okay, I'll go ahead and break this video into smaller chunks, so we'll come back in the next video immediately and say, hey, well, how do you do anything interesting? How do you say what is 2 plus 2? We'll come back and call a function.